Okay, welcome everybody. This is the second technical workshop on CVII at this all-member meeting. Once again, we have a few presentations and hopefully some time for discussions. Please participate actively. As I said, the session is recorded and will be made available at a later time as well. I thought I would start by just a brief overview of the technology stack development. So as you can see on the agenda here, we will soon have a little bit of a deep dive. Sorry, this is a little mistake here. Why don't we fix it right away? There we go. We will have a presentation by Piotr, focusing on AUTOSAR, and then later we will have Magnus speaking about the vehicle service catalog. And we'll put Magnus last because it's still very early time in the Pacific time zone. Okay, so for the technology stack, I thought I would just share with you briefly how we look at this concept. Let's see, share. Get the right screen here. Desperately trying to get WebEx out of the way. Okay. So let's speak a little bit about what we mean by technology stack first. You may have heard this in previous introductions or definitions, but very roughly, we put this term to describe all the software that is related to the transfer and use of data and services that adhere to the common models that we're aiming for in CVII. And it's really enabled by the fact that we have a common model to describe everything, both the standardized interfaces and standard data catalogs, as well as potentially additions to those that companies want to make. If it's all using the same description formats and same meaning and semantics, then we have the opportunity to create this strong technology stack together. And we're all talking here about just communication protocols, basically bindings and mappings to existing technologies that are in the automotive space. And so we should agree, hopefully, that this is not differentiating technology, and it is technology that we should just get out of the way so that the real challenges in automotive can get those resources instead. And we also have the opportunity, if we work on this common technology stack, to really get it right. There's then the opportunity to put the effort of making it properly secure and safe, which is of course critical. And I don't see any other way that it can really succeed fully. I mean, there will be cars built for sure in the future, but if we really want to get the full potential, then we need to do this together. And so if you haven't been part of this work before, just want to show you that we're analyzing this work a little bit in our weekly meetings. We've talked about the key technologies that may be popular in the industry. MQTT obviously being one of those, typical pub/sub technology for VSS. That's a bit of a no-brainer. AUTOSAR is an important technology. We have had This is just for comparison that we have had in the past demonstrated the ability to do Franca to AUTOSAR XML conversion and reverse. And you could potentially use this this tool chain today. It's been demonstrated with a some IP stack and communication then between kind of a non-AUTOSAR side and an AUTOSAR side. And theoretically, of course, you could use DDS as well. But this is a somewhat complex tool chain, so more likely we're looking towards something like this. And I think Piotr will guide us through some ideas around that, where we can map VSS and VSE being the working names for what we envision being the standard models for data and services, and to map that into the AUTOSAR world. Then, of course, we just finished up the CCS Cloud and Connected Services workshop, and that's one of several projects that are all part of a greater whole, working on figuring out the technologies and the architectures and frameworks that can be used to build the complete system. And so this is also part of the technology stack. If you saw Bosch's demonstration the other day, then you're familiar with part of the big, very nice framework that is now open source, maintained on the GENIVI GitHub site, and that too is likely a very nice building block for building a complete technology stack. So that's the Vehicle Edge and IoT Event and Analytics projects. So what we're essentially doing now is trying to lay the map overview of the existing technologies and of course starting to build a view of how to build a complete system out of these softwares and other existing open source technologies that are out there. We're also discussing from a specification standpoint, of course, agreement around standards there. You could say that the vehicle, the technology stack for CVII, you could say that it could be defined as specification, or it could be defined by running software, presumably primarily open source license, because that makes it available to all in a very direct fashion. I could, of course, envision a scenario where there's enough commercial vendors of software that it is widely available and without a lot of obstacles. But open source is generally the easiest way to really achieve that widely in the industry. And so that's up to all of the participants to feed into that and to steer the direction towards code development and or specification development, like in the case of the W3C-VISS protocol, where there's a formal specification, and then of course there are implementations being made that follow that specification. So that's an introduction towards technology stack in general. If there are any questions on that, or potentially on previous topics we've covered earlier this week in CVII, then we have a little bit of time to discuss that now. So if you remember in workshop number 1, we did have a number of questions that didn't quite have time to address. So if you want to bring those up now, that's perfectly fine. We discussed about the alignment process across standard bodies. We went into some details about how this might work on AUTOSAR, Sensoris, and generally speaking, the steps that were needed there. Bring up the chat window here. So people were very talkative the other day, but today you seem to be a bit shy. If you're new to this project, I recommend you take the chance to unmute, present yourself, and just share your thoughts. Okay, it's very, everyone's very shy today. Then I propose we continue with the presentation from you, Piotr, and then we may have some, hopefully some more discussion sparked from that, I hope.
Okay, so let me share the content.
Yeah.
Just a second, it's so simple that I don't know how to do it.
It's okay. People are joining the meeting in the meantime, so I'm sure they don't mind.
Okay, I hope I was able to do it. So
Yes.
Can you see the screen?
Yes,
Okay.
it looks good.
So as Gunnar mentioned, one of the topics that we started is how to get into this AUTOSAR world, how to connect to the AUTOSAR world. AUTOSAR is quite common, and I guess that there are a lot of companies, a lot of people that are familiar with AUTOSAR, and a lot of functionality is delivered by this AUTOSAR solution. And from our point of view, or at least from my point of view, this AUTOSAR provides some services that are defined with ARA framework, ARA XML actually, and they're communicating between each other via some IP and TCP company. The problem with that is that it's quite closed ecosystem. So the interfaces are already defined. The implementations are mostly commercial, which is quite nice because there's a great support, but for our purpose, it's not very suitable to experiment. There is this demonstrator project within AUTOSAR that should somehow prove the specification and provide some playground, but you need some kind of a special access to get to that. But nevertheless, how to get to this AUTOSAR? I guess that one of or at least my ideas was to somehow target this some IP layer. But the problem with that seems that this is kind of a hacking way. So the some IP is okay, it's a nice protocol, but it's not a very good layer to get the actual data that services should serve. So the second approach was to target this ARACOM layer. And as Gunnar mentioned, there was already some work done in this topic, this Farrakhan tool, that actually successfully connected GENIVI components and AUTOSAR components in a way that they were able to create the services with Franca IDL, definition language, and communicate them with AUTOSAR model, these RXML files. In order to do that, the whole runtime environment also have to be somehow developed, because on AUTOSAR side, the RxML are used to generate skeleton and proxy, and the proxy can be used by the client application to communicate with the services implemented by implementing the skeleton part. And the skeleton with a proxy communicates with some IP. So together with Farrakhan, you've got also approved working that this can be done, and it works using vSIM-IP. The demonstration, as far as I remember, was shown so that some AUTOSAR, I guess, image processing component was used to check to analyze the image and check any obstacles and run emergency braking procedure. So the chain was successfully established, containing AUTOSAR components and GENIVI components, and they seems to be cooperating. So this is one of the approach that, as Gunnar mentioned, it is quite complicated. It's not very clean. You have intermediate steps, because from VSS you have to generate this Franca definition, and then from Franca and then you have to connect Franca definitions with RxML. And connect these two services via some IP. This is how it should look like. So this is quite complex, but at least this should be working, and we've got every blocks available. What we would like to have is much simpler approach, so that we can use this vehicle service catalog directly together with RxML. We haven't explored it yet, but I guess that this is a target. This is much cleaner solution, much straightforward, and this is something that we would like to achieve. What we actually would like to do now, some real activities, is to establish this kind of a setup to prove that actually the values can be taken from the AUTOSAR world, so that we would like to set up the AUTOSAR application, use the Farrakhan environment and toolchain to communicate it with a component that will at the same time serve as a feeder to the QXAVAL, already mentioned QXAVAL framework, so that it can be read by a client, and the communication can be then made based on the VSS data model structure. The topic that remains is accessing the values that are served by a signal from the classic AUTOSAR, and this should be covered by the component that was already announced a year or 2 years ago within AUTOSAR specification, this signal to service. This component, I believe, is not yet existing even in demonstrator, and there is no plan to introduce it in demonstrator. I guess that some commercial stack have corresponding components that are actually doing the same. Some they are exposing service that lives as an adaptive applications, and somehow catching the signals from the classic world and providing it as a service in adaptive world. And that's the plan for kind of a proof of concept that we would like to have, and I guess that we are doing it right now. So that would be all from the presentation I prepared for you, and waiting for your questions. So if there are no questions, maybe I will ask some questions to the audience, because I guess that using this layer is not the only option that we can have this ARACOM, because the communication layer in adaptive also consists of this restful API and the whole restful communication. This is a topic that wasn't much analyzed by me, and I would like to ask the audience if what you think, if this is feasible to utilize restful RRest specification for communication with non-AUTOSAR components, or this is not the case. Maybe this is something that we can discuss, or somehow someone.
So you're asking if a RESTful interface between components is possible?
To utilize the RESTful communication that are specified by AUTOSAR.
Well, I can't answer that because I'm new to the AUTOSAR, so I'm learning this. But we've created our own protocol for communication between car components and then implemented it. It's called CCDL, and it was really created very simply for prototyping, and it uses HTTP and RESTful interfaces. So the issue we would have with it is whether it is efficient.
So as for the AUTOSAR branded solution, there is already a specification for that. So the question is if someone have already some knowledge about it that can share with us.
Yeah, or done some analysis or have some ideas. I mean,
and is it even, I mean, I'm also not so much into AUTOSAR, but is it even used? Because I mean, AUTOSAR specifies a lot, but in the implementations or in usage, you don't find so much. I mean, ARACOM you find, and some IP you find. I'm not sure about this.
Why is it being specified if? Why is it being specified if it's not? Maybe that's that's an open question.
Well,
that's the same as 5G, and that's normal.
That's why the reason why I think that this entry level for AUTOSAR request is quite high. There's just enormous amount of specification and documentation on highly detailed level that it's not easy to actually get into it.
Yeah. Well, one thing is clear for CVII, we're looking towards alignment and finding consensus in the industry about selected technologies, and of course starting with the models which are the most important. But I mean, it should all be usable, and it should be work that is going towards convergence and not specifying things because it's possible to do. I'm curious, for example, Gary, you didn't present your company, but
sorry, Indigo Corporation. We are a small tech software company in Toronto, Ontario, and Tokyo, Japan, which creates interactive agents, voice-based interactive agents, and we've done various agents in vehicles for over a decade, and we're currently working towards providing voice accessible manuals, car manuals.
Right. Yeah, I guess what I'm leading up to is that there are quite a few established technologies out there, and most likely, companies or some kind of consensus building like this will build around a wide standard. But it's always possible if you're thinking of if this is an open specification or something that what you have created, then there may be ideas that influence an agreement on how to do communication, and always open to hear from engineers on that topic. But yeah, of course, we could say just for sake of completeness that the principle of restful doesn't really require HTTP. It's more of a principle of how you build the interfaces, but in practice, it really usually implies the use of HTTP. And it seems to be that way also in the AUTOSAR specification, that HTTP was mentioned. It's clear that
there is binding.
Yeah, it's clear that we are looking. We as a collective in all of the participants in the CVII related projects, we're looking at kind of web-like protocols for the usefulness of that, especially when you start connecting to web-based technologies, whether that's in the cloud or in the vehicle, if you have a kind of user interface implemented in web browsers and so on, then a JSON-based and web protocol base is very natural. And the VISS is an example of that, and there's discussions in that group as well as in CVII in general about, of course, kind of efficient binary encoded protocols as well. Some of these, like SOMIP, generally imply that, although they don't specify typically how the payload is transferred, only to some extent. For MQTT, there's no such specification, and you have to fill it with your own payload. But that's part of the work here to also look into really efficient protocols for use inside the vehicle. But the evaluation of HTTP and or restful protocols, that's how you decide, is by benchmarking, sharing the results, and then finding consensus. That's my view.
Okay, well, what about WebSockets, for example, which would be a modern way of communicating via web protocols?
Yeah, so VISS, for example, the W3C standard, I guess we could call it a standard web protocol for car data. This supports HTTP and WebSockets, so both are available. And the data encoding is a JSON-based data encoding for in the default, but there's, of course, as I said, discussions about other potential ways to do it if it's more efficient to have a binary or compressed encoding of some sort. But yeah, that supports WebSockets directly. I think a lot of times we are looking at existing technologies. I sincerely doubt that the industry needs to invent new protocols and encodings. It's about picking what's out there and finding consensus around it. That's the first thing, and B is to talk about perhaps more about the general principles than the actual transport. I mean, moving things from a WebSocket to a native socket or a Unix socket is a trivial change. I don't think that's the detail level that is very challenging to discuss. At some point, implementations and specifications have to specify those details, of course, but it's the big picture that is more important at this moment.
And this, you mentioned WebXML and WebSocket, sorry. This interface should be, or will you see the application between, let's say, this non-AUTOSAR and AUTOSAR components, or somewhere here between kind of an aggregator and the client, the reader?
I didn't follow that, Piotr.
And because here we have the interface between AUTOSAR and non-AUTOSAR world. In Farrakhan, this will be most VSOM-IP and TCP. And here we have kind of central aggregator in our system, this QRAD, and the client that would like to access the communication. The question is what this WebSocket interface should be applied here to communicate between AUTOSAR or somewhere else in the whole infrastructure. Yeah, because this AUTOSAR connection is just a piece of the total infrastructure that will be existing.
But again, I'd answer that on two levels. On the one level, I don't think it's so very interesting challenge to talk about how you set up the actual WebSocket. Is just a way to set up the socket. It's to get the pipe, right? That's not a very challenging detail. However, specific technologies like some IP have all of that defined, and so it's not a question of inventing that. It's just following whatever the specification and or particular implementation provides.
Yeah.
So
actually, that's the point.
If you see what I mean, right? So it's a detail level that, of course, needs to be worked out, and you do that by creating working software where you try out the proof of concepts. But it's not a high level sort of strategic discussion in my view. That's on a different level.
But I think there is a difference. I mean, on the left side here, where the QRAD aggregator VSS is living, I mean, okay, there obviously, I mean, if we're choosing standards like W3C, VSS, there is WebSocket. And I guess that also makes sense because it's like some higher level thing. I mean, Gunnar, you're right, there may be a million of other ways to achieve the same. But as you also said, I mean, this WebSocket and JSON and these kind of abstraction levels seems to be the right one. And I think they are also valid, to discuss how to, and you can discuss technical details. And I guess on the green side here, and actually also this slide, I see there's classic AUTOSAR written on the headline and adaptive AUTOSAR on the green box, which also are a little different things. But there I really guess, I mean, we have these thousands of pages of AUTOSAR specification. Not all of that is live out there. So there probably nobody needs to invent something. And I would also assume that, I mean, for classic AUTOSAR, I mean, on that side, probably some IP is the most advanced thing you will get, right? They will not go further. And for adaptive AUTOSAR, I think it's still very much open how much of that will be used and what they will specify and what will come on top. So I think the green side is really try to adapt everything that is there, but don't try to change it because that's hard and probably not worth it.
That's the point. Sure. And actually, difference to for the classic AUTOSAR is here. So that there is this signal to service specification that should allow to access classic AUTOSAR from adaptive world.
Okay. Yeah. Okay.
Yeah. Agreed. So great conversations. We only scratched the surface. Happy to hopefully see some of you who are in this workshop get in contact more times, and we can delve into this a little bit more, because it should be relatively simple, I think, to get a shared view on how things are and where we are going. Which might be hard to get the whole view here.
So yeah, thank you for your time.
Yeah, thank you, Piotr, for this this starting point. And I think you're all curious. Yes?
Yeah, Philip speaking. There was an interesting question raised by John Masker in the chat. You have time
to I see it.
Get it now, or you want to look at it later?
I would propose we let Magnus start his presentation on services, and maybe then we can delve into this question. It's also possible to use the chat for a little bit of discussion, of course. Okay. So just to make sure we have enough time, are you awake, Magnus?
I believe so, yeah.
Great. Let's start talking about how we may build a standard way of describing services and interfaces.
Yep. 1 second, I'm going to share my screen here. Let's go into full screen mode on top of that. Can you all see my screen?
Yes, but we're seeing the speaker view. So if you go to the display settings on the
Spoilers.
Yeah.
and
Let's see.
just go to the menu, say called display settings. I don't think you need to stop sharing.
Okay, wait, okay, obviously this was not 6 o'clock in the morning here, so please bear with me.
Yeah, there's a way to switch the screens in PowerPoint.
Oh, okay, so it's a PowerPoint thing.
Yeah, here we go. It looks good now.
It does?
Yes, we're seeing full screen slides now.
Okay, cool. So, welcome. I'm Magnus Feuer. Have a fairly long background in automotive software engineering. I've been working on everything from the earliest day of wireless car, which launched a telematics service for Volvo, and a number of startups. Been working for Jaguar Land Rover as a chief system architect for the telematics portion for many years. Currently, I'm working for Toyota, but I've always been kind of looped in with GENIVI and the work that Gunnar and Steve and everybody else are doing here. And about a year ago, a little bit more, we realized that we inside JLR needed an upgrade from the VSS specification, the vehicle service specification, and we started working on the service catalog itself. And we are currently in a position where we are still discussing a lot of core concepts, what goes into the service catalog and what goes out of the service catalog, what does the tooling look like. We're at the very, very tail end after an interesting journey with attorneys to publish some proposal sourcing to source code to and open source that so that we can actually generate the things that we're going to show here in this presentation. The presentation has been cut down a little bit because we only have 25 minutes and we want to leave a little bit for Q&A, so it's not the whole thing, and it focuses mostly on the hard technology, because I believe Gunnar already has talked to ears off about the awesomeness of everything else that's going on and why this is needed. So this is a part of CVII, obviously. So I'll dive right into it if I can. Let's see. Here we go. So if we, sorry, there. What we are doing is that we're looking at standardizing a service catalog, which is pretty much just yet another IDL file, an ideal way of specifying an API that consists of methods and events and data structures that we want to normalize and be able to transmit and be able to access. We want to be able to define a number of interfaces, and we want to be able to implement these interfaces in a number of different languages, and then also be able to access these interfaces over a number of different protocols. So what we did, a little bit unlike other solutions out there, was that we decoupled the IDL file from the target language and from the target protocol. So you can now pretty much mix and match both editions in any way you want. And here is an example where you, for example, have a remote configuration, and it really is a single API where you want to set the right front temperature, but you want to be able to do that from a mobile phone on your left and be able to send a standard REST HTTP interface or call up to a server in the middle in the cloud. And from there on, you want to continue through, for example, gRPC to make a call into the vehicle itself. And here we can, this kind of links to the bridge between AUTOSAR and the wider world, which we spoke about earlier as well. And the idea is that we specify the service once, and then we generate everything that is needed on a per language and per platform and per protocol basis, so that you can do a native call from the Kotlin application on the left, get that set default temperature call into the Python server in the middle, and that then gets forwarded to IVI, the IVI system itself. And none of these three applications written in Python, Kotlin, or Rust will be aware of the underlying calls. They will only kind of work on the assumption that I'm making an API call and the magic will happen. This also helps with testing a lot. You now have a clearly defined interface that allows you to do focus on interoperability and integration testing instead of unit testing or per ECU testing, which having a couple of years from OEMs under my belt now is always a huge issue and a source of cost and delays. So in a similar way, we can also deploy the same thing and use the same technology to do internal ECU to ECU communication as well, where you define the payload that in this case want to transfer over Oracom, some IP or something like that. And you now generate the specific libraries as well for different protocols and languages. So it is quite flexible. There was a question early on, do we focus on off-board communication, as I showed in the previous slide, where we set up a number of external facing services between the vehicle and a backend or the mobile phone, or do we focus on in-vehicle services such as shown here? And the answer for now is both. We'll see if we start to focus more on one side or another as we move along. But for now, we're just going to focus on both because we actually are solving the same problem of how do you describe interoperability and interfaces in a non-technology bound manner. So moving on, and again, we're going to dig straight into the meat here. The IDL file itself, service catalog file, and we're probably going to find a better naming convention as we move along because the current name service catalog means both the file format that we're looking at, the actual catalog of services, which is one of the goals here, and also the tooling itself. And it's getting a bit confusing, so we're going to fix that. So it's fairly straightforward. It's YAML, and I'm going to explain why it's straightforward in a bit. It's YAML with namespaces that obviously can be nested. And inside a namespace, you can define your data types, which is just enumerators, structs, which obviously can be nested, and dump type defs per se. You have methods that have in values and out values. You have events as well. Which also can carry in values. All this is pretty much stolen. The methods and events thinking is stolen from some IP. What we did not have currently and what we need to discuss is how do we integrate the VSS signals, which are more of a property style thing. So they are more of a distributed data, while events are more triggers of actions. And that's an ongoing discussion that we would love more input on from participants and gets kind of external influence on, because that is always good, especially if we have kind of real life experiences from the markets. So if we look at the data type, and this is the actual code generated, we simply have a setup where we from a data type can generate, in this case, we use Python because it's easy to kind of talk about and easy to describe. We can generate the corresponding classes straight off. And this can obviously be nested classes as we do here, or we can go deeper into in C++ and do other solutions or whatever the target language requires from you. So that's fairly straightforward. If you look at the method, you will get two stub codes pretty much. One that is the get config server on the server side, which will just retrieve, which will call the implementation of get configuration value, which the developer, the application developer themselves support. So it is a simple stub code in this case. And in the client code, we will call the implementation. We will call the dbus version here to get the call over to the server side. So this code on the right-hand side is bound to PyDbus, which is one of many dbus implementations. Again, it's mostly for demonstration purposes, and you can replace that protocol with whatever you want, and I'll show you how that's done. Finally, we have events, which in this case are implemented as just dbus signals per se. And you can either emit them or you can receive them. PubSub currently, the actual setting up of signals is currently outside the interface definition, and we try to keep a very strong separation between the interface definition and the implementation. And we do that through something called deployment files, or deployment structures. These are files which is stolen directly from FrankIDL, by the way, where we augment the interface files with build time information that is necessary in order to freeze a set of services together with given names, IP addresses, configuration data that's not supposed to be changed, and other bits and pieces, protocol setups, you do big endian, little endian, etc. So when you generate your code, you provide the IDL file itself from the previous base and one or more deployment file structures, and that will generate the code with everything necessary pre-configured, so that you don't have quote unquote dangerous configuration options live in a vehicle where they can be changed by an OTA update, for example, and start to mess things up. There is usually a little bit of confusion of what goes into a deployment file and a configuration file, but I've noticed, or we've noticed, that things tend to settle fairly automatically when you face, the actual, when you sit there and write your interfaces and implementation, and it does have a very specific place in the development cycle. And finally, we have the ability to import things. That is really, really important when it comes to importing global data structures. Error codes is a very good example, but also interface files. If you, in the configuration service, for example, you may want to have a set of services or API calls that subscribe that are to be invoked when a specific value changes, almost like a pub sub, but you want to implement it as a call. In that case, all the clients that are to subscribe to a specific change for a configuration value, seat settings or something like that, needs to implement the callback interface itself. At the same time, they don't want to import the entire structure or redefine the entire API for the configuration service. They just want to import a lightweight interface and implement that. And that allows the configuration service itself to do a callback to the client, knowing that, yes, this is correctly implemented and everything. So imports and deployment files are crucial. And this we have live data on from Jaguar Land Rover, if nothing else, where we did not have this in the first iteration, and everything just came to a screeching halt, and we went, oh shit, we got to fix this pretty quickly, which we did, and end up like something like this. We need this in order to scale real life projects where you have 100 plus ECUs talking to each other and more than 100 services talking to each other in such a way that build time, you need to be able to decouple different services and rely only on the interfaces in order to get the necessary build artifacts in place so that you can build your little local binary. I know it sounds far out there, but this is a huge problem that a lot of existing IDL solutions out there tend to miss because they do 2, 3, 10 services. We have hundreds of services, and scalability does become an issue, and you tend to lose track of what's going on after a while, especially when you roll this into automated test, variance management for different markets and vehicles, and just automated build as well. So that's where we're kind of pushing for this. And finally, how do we generate the code for Python, etc.? So we use Cheetah template files. We're probably going to change to Jinja, which is, both those are template generators originally built for HTML, so that you quickly could spit out an HTML file with kind of built-in almost JavaScript-like code, but a little bit better. And it works equally well to generate Python code or C++, Rust, and in this case, an XML introspection file, which is actually what Rust picks up at the end of the day and generates the necessary Rust stuff. So what we can see here is that once we have parsed the file, and I'll go back now, for example, this one on the left-hand side, this YAML thing becomes obviously a Python dictionary that's available. And this Python dictionary is then passed on to the generator itself that now immediately, for example, have access to the interface name, which is dbus interface, and that's picked up from the deployment file. And we can loop over all the commands that we show there, and we can emit the right command name, and then we can loop over all the input arguments for that command, generate necessary XML code for that, and then kind of cycle through the nested loops. And at the end of the day, this will actually generate a valid dbus XML introspection file. So we've done this for Python, we've done this for Rust, we are going to start adding support pretty soon for C++ and C as well. And again, it's just one IDL file, and right now we're using dbus, but we will probably move on to other protocols as well. This decoupling has allowed us inside W3C and GENIVI to do a try before you buy scheme, where we can just pretty quickly throw together a protocol setup and say, hey, we've agreed on how a configuration server should look, and we have an IDL file for it. Let's try out gRPC or a REST protocol or some IP just to see what it looks like, so we can talk about actual trial implementations instead of theoretical constructs. And that's going to be very interesting to see how well that strategy goes forward and how well it allows us to hone in on a really good solution that we can say, okay, this is the standard we're going to go on. And the final note is also that it allows OEMs and tier ones and other agents to write their own template files that suits their specific needs. And that allows them to implement a standardized service, configuration, seat, HVAC, radio, etc., but targeting their very specific and proprietary environment. So next step is I'm in the tail end of open sourcing this. I was hoped to have it done today, but it is there's some holidays going on, so I didn't have access to legal, but I think everything has been cleared by now. I've said that before, but I am somewhat hopeful. It's been a long process. We need to figure out how to integrate the vehicle signal specifications, which are these kind of properties, more of a distributed state, and how they're going to interact with everything else. And we have several proposals there. And again, we're probably going to do some trial coding to see what looks best, and then we're going to work on it. We need FrankIDL import and export. As you saw, the YAML format is fairly rudimentary. And we kept it that way. The idea is always that you have front-end translators and maybe pluggable front-end parsers. I've been doing some work writing parsers lately for internal stuff. And we may be able to actually have one or more pluggable front-end parsers that can consume FrankIDL or other IDL formats, and then normalize that to this internal YAML format, or the Python directory structure or dictionary structure that backs it, allowing us to pretty much be compatible with several different systems out there and act as a kind of a bridge. We don't want this to replace FrankIDL or all the other things out there. We want this to integrate those systems in a way that they can talk to each other. And to minimize the manual labor, which is also a big risk, because that's a small issue with the protocols, and implementation on that level tend to destabilize entire projects if they're not done right. So we want to automate that as much as possible. Then we do a lot of try before you buy and a lot of internet nerd sessions where we focus on how to integrate with AUTOSAR, which internet protocol we want to use at the end of the day. And meanwhile, in parallel with that, we start to create the actual service catalog itself, which is going to be a set of non-differentiating services that can be commoditized. And I mentioned a couple inside the infotainment system. We have HVAC, we have radio tuners, we have seats, ambient lighting, locking, unlocking, configuration, all those things that everybody needs. And we keep reinventing again and again and again in various OEM projects when we do a new electric architecture. So we want to give the industry a higher starting point by providing these service definitions and maybe a reference implementation, since we can now generate the majority of the code for that up front and say, use this instead. And there's many, many reasons why it's a good thing for the OEMs and for the tier ones, and it helps the industry kind of move forward at a higher pace is the idea. And that's all that I have in my somewhat limited time. So I don't know how much time I have left, Gunnar. It looks like 3 minutes, but at least we should be able to take a few questions.
Yeah, that's right. We do need to wrap up fairly soon. There was a question about why use a YAML-based format as opposed to the standard FrankIDL.
Yeah,
Do you have some thoughts about that?
The YAML-based format can be seen as an intermediate format, almost like an object code format or an artifact format. You can definitely specify your services there, but we wanted something that is very, very easy to process on a machine level and at the same time is human readable. And YAML has its issues, but it's easier to read in JSON. And definitely XML. Sorry for being a bit prejudiced here, or having an opinion about it at least. But we need to find out, what format will we use in the service catalog eventually, and maybe we want to find another format and write a small parser for that. We definitely have the option to do that. We just wanted to start off with YAML because it's like the smallest common denominator that we definitely can translate to. But as I said, nothing is set in stone. This process has just started, but we wanted to get some tooling in place before we start nailing the actual standard itself.
Okay. Yeah, that makes sense. And of course, this is an open discussion. There are a couple of drivers. Similarity with VSS is one. We found YAML to be a very useful format there for many reasons that we can go into, or you can review the community slide deck where we all have all these details. I want to mention two things, which is in the interest of, not reinventing the wheel, and that is the existence of the Open API or Swagger standard for web APIs. And there's a similar one called Async.io, which is essentially for event-driven systems. But what we're speaking about here is, and it's also the scope of Franca, is a generic interface description language that doesn't assume RESTful interfaces or event-driven interfaces, but rather have one language for all of them. I would say there's a third category, which is kind of the normal method call you would have on inside of a programming language, or normal function calls that are synchronous. And so, putting all of this together, we should try to stay close to those other standards, but create a single consistent language. And so it's about getting that compatibility that Magnus mentioned, and having putting the best parts of all of these things in without overlapping or reinventing things where not needed. So that's my view on that, and why they're also, when you look at Open API and those, they are described in JSON or YAML. Typically, if you want it readable, it's in the YAML variant. And so you have other technologies like that drive a little bit towards that as well.
Yeah.
But open for discussions and more input on this. We do need to wrap up because we have the Android session starting, and we need to run those sequentially.
Yeah, I am available on the Slack channel that we have for W3C if anybody needs me. There are a number of OEMs who are engaging with this, and we don't know if it's going to take off yet, just like we didn't know with VSS, but it definitely, the timing seems right and the interest is there. But it's an early phase in the process, and now's your chance to influence.
Yeah, VSS, took a number of years where it was there as an option, and now it seems like the time is right, and everyone's looking and seeing here's already we already have it here. Let's just go for it.
Yep.
And hopefully we can think similarly about services standard in the future.
Yes.
Thank you so much, Magnus, and thanks for the participation of those involved. I do hope you join us for further discussions in the normal weekly meetings. If you follow the references, you will find it, and you're welcome to contact any of us directly. With that, I will wrap up the session, and again, thanks to everybody.
Thank you, guys. I'm going to check out. Have a good one.
Bye-bye.